All right, guys. Today is the second day of using exponents. We're going to actually talk about how to use exponent rules with variables today. So we're going to have 5 different exponent rules. You actually kind of learned 2 of them, the negative power and the 0 power one yesterday. But we're going to talk about 3 more of those, and we'll kind of go through what the rules are, and then we'll go through a couple examples. So first, we have the multiplication rule of exponents, and the multiplication rule is essentially what happens when you have 2 things, a x times x to the a times x to the b, and it's what happens when you are going to be multiplying those 2 things together. So for example, I'll write a little example up here. Let's say you had x cubed times x squared. And we're going to expand that kind of like we were doing with stuff yesterday. So x cubed, that's the same as 1, 2, 3 x's. And x squared, well, that's the same as 1, 2 x's. So if you were to combine all of those, you would get x to the, well, that's 1, 2, 3, 4, 5. 5, right? So you get x to the 5. So when you're combining things with multiplication, another way you could have done that quicker, instead of just expanding everything and then adding those things all up, we could just say, what's an easier way to get 5 out of 3 and 2? Well, 3 plus 2 is 5. So when you have exponents like this, when you have 2 things that have the same base, the word base refers to the thing being raised to the exponent, but when 2 things have the same base, you can add their exponents. So in this case, you would get x to the a plus b. So that's it. I'll show you another more complicated example so that we get kind of an idea of what this is going to look like on a bigger scale. So for instance, let's say we had 2x squared y to the third times 3x times y to the fifth. All right, so we got a bunch of different variables. We've got a couple different numbers. How would you combine all of this? Well, the first thing that we're going to do, we're actually going to combine the numbers, and that rule doesn't change. So we have a 3 and a 2. Don't do the exponent rule with those 2 numbers because those aren't exponents. Those are coefficients. So 3 times 2, 6. X squared. Well, we'd combine that with the x over there. If the x is by itself, that's a 1 over there. So x squared, and we're using the multiplication rule with an x to the 1, so that becomes x to the third. And then y3 and y5, well, you combine those and you get y to the 8th. So that is what you would get when you are using the exponent rule there. So we add the exponents on the bases. You have to make sure you're combining the bases, or the things that have the same base. So combine the y's with the y's, combine the x's with the x's, etc., etc. Let's talk about the division rule. So the division rule, x to the a divided by x to the b. What's that equal to? Well, I bet some of you might have a guess, but let's use an example. So let's say we had x to the fourth divided by x to the 1. You don't have to write out that many. So we'll expand that again. 1, 2, 3, 4. And we just have 1x on the bottom. X to the 1 is just 1x. So if we were doing division, you may notice that we have, we can like cancel out 1. So x divided by x would just cancel out. And in the end, we'd get x to the third because that's 1, 2, 3 x's, right? So a quicker way that you could have done this, let's look at these numbers. So we have x to the fourth and x to the 1. What can you do with a 4 and a 1 to get a 3? Well, that's definitely subtraction in that case. So if you're going to be dividing things that have the same base, that means that we're going to get, in this case, x to the a divided by x to the b. What do we do with the a and the b? Do a minus b. So that's what you would get. Again, we'll do a more complicated example. So let's do like 12x to the 9th, y to the 7th, divided by 3x to the 2nd, y to the 5th. So again, let's start with the whole numbers. And again, we don't use the exponent rule with those. Those are just normal numbers. 12 divided by 3 is just a 4. Don't subtract there. But here, x to the 9 divided by x to the 2, well, that is going to be, make that look more like 9. That is going to be x to the 7, right? 9 minus 2 is 7. 7. And here, y 7th divided by y to the 5th, well, that's going to be y to the 2, right? Because 7 minus 5 is 2. So that is going to be our answer right there. So that's how you do the division rule. You just have to subtract the exponents. That's it. The final thing we're going to do is power to a power. So what happens when we have x to the a being raised to a b power? Well, let's write that out again. We'll do a little example, and then we'll do a little more complicated one. Let's say that we had x to the 3rd squared, right? So we're going to expand this. I'm only going to do it a little bit, not all the way. X cubed squared. Well, squared means we multiply that by itself. So we have 2x3s. So that would be like x3 times x3, right? Well, we got an x3 and x3. That means we have 2 of them. So that means that we have to, well, we're doing multiplication now. So 3 and 3, what do we do those? We don't multiply the 3's. We're going to be adding them. So that becomes x to the 6th. That's the multiplication rule. And what's an easier way to get 6 out of 3 and 2? Well, instead of having to expand it like this, you could just multiply those numbers, right? So if you have some number or some power being raised to a second power, we can just multiply those two things together. So for instance, x to the a to the b, well, that'll give us x to the a times b. All right. So again, we'll do an example there. For instance, let's say that we had 2x, 5y, 6 all cubed. Well, let's go through. Again, we have a whole number. We got to figure out how to treat a whole number. And again, we don't do the exponent rule with that. So we're going to kind of distribute this 3 to everything. So 2 to the 3rd, that is a power on the 2. 2 to the 3rd, well, that's 8, right? 2 times 2 times 2. That's going to be 8. Well, then we're going to do x to the 5th to the 3rd. The new rule, we're saying that if you have a power to a power, we're going to multiply them. 5 times 3, well, that's going to be x to the 15th. And y to the 6th to the 3rd, well, that's going to be y to the 18th, right? Because 6 times 3 is 18. So you got that. So that's about it. The other two are things that you've seen before. So 0 powers, anything x to the 0, well, that's going to be 1. We talked about that yesterday. That can be anything. So if you had like negative 217 x to the 3rd, all to the 0 power, well, anything, there's a lot of stuff in there, right? But anything to the 0 is just 1, so we can just do that. That's pretty quick. That's a really quick rule. So that's easy to remember. Anything to the 0 is 1. Another thing to remember here with the x to the 0, let's say you had x to the 0 times y3. You could simplify that just as y to the 3rd, right? Because x to the 0 is 1, we can just eliminate that. So that's another way that rule will show up. Finally, negative powers. We talked about that yesterday. Let's say x to the negative a. We talked about how those make fractions. So in this case, it's going to be 1 over x to the positive a, right? Anything to a negative power becomes 1 over that to the positive power. So let's say you had x to the negative 5th. You'd write that as 1 divided by x to the positive 5th. Or let's say we had 3x to the negative 2nd, y to the 3rd, z to the negative 5th. It's got a couple different variables there. Well, if I see negative powers, I know I got to get a fraction, so we put the fraction bar on. And we're going to go through and we're going to figure out what parts of this term are going to be on the top and what parts are going to be on the bottom. So start with the 3. Again, it's a normal number, so we're just going to put that on the top. X to the negative 2, well, negative means it goes on the bottom, becomes positive, so that becomes x squared. Y3 goes on top because it's positive, and Z5 goes on the bottom because it's negative. So that is what you do with negative powers. And that is all 5 power rules. It's quite a few of them. So I'll upload this, and I know it's kind of confusing, so if you have any questions, please come into my office hours and ask. Good luck, guys.